Okay, let's go again, work starting on the transforming it. So we're going to do the 6.2-2 today. 6.2-2 is the combining part of the transforming and combining of random variables. So earlier, so go a little bit of review. Okay, so earlier we said that if I had a random variable of x where I have mu of x and I have sigma x, right? And if I go ahead and add a number a to this, the new mu is going to be mu sub x plus a, right? The standard deviation does not change, it's still going to be the same, right? So this is if I add a. If I multiply a, I get what? I'm going to get a times mu x would be the new mean. And the standard deviation does what? Also, we're going to multiply like that. Okay? So we talked about individual random variables, what happens to them when we add or multiply, for that matter, when we subtract or divide also, right? Okay? So this is what we talked about. So in the 6.2-2, we're going to now talk about combining random variables. So I have two different random variables now. I have x and y, where I have like this. So I have an x random variable and a y random variable. So what is the mean or mu of x plus y? Well, if this is the mu for x and this is the mu for y, it makes sense that the combined new mu is going to be nothing more than we're going to add those two together. Okay. If you were to subtract them, you would just subtract those two. Okay, that's pretty simple. Okay. The interesting thing is what happens to the standard deviation when you combine random variables. So the combined standard deviation, okay, if you add them together, is going to be like that. Okay? Interestingly enough, if I subtract, okay, so let's go ahead and actually do this in a different color. If I subtract, it's going to be subtract here, right? We talked about that. If I subtract here on the sigma, on the standard deviation stays the same. Okay, so regardless of whether I'm adding or subtracting, when you combine two different random variables, the resultant standard deviation still stays the same here. Okay, there is no negative here, okay? It is still going to be sigma x squared plus sigma y squared, and then you take the square root of that, okay? And that is in a series of green boxes on 388, 389, and 390 and 391. So go ahead and flip through those all the way through 392 and see if that makes sense to you. Okay, the first green one says that the mean of a sum, okay, and that would be the one up here, the sum. Okay, and then the next one would be the difference. That would be the difference here when you are subtracting here, okay? That was on page 389. If you flip the page and go to page 390, it says independent random variables. If knowing the value of x does not help us predict the value of y, then x and y are independent random variables, okay? So we are adding here independent random variables, okay? We're adding and subtracting independent random variables, okay? So they're not tied to each other is what we're saying here, okay? So on page 391, it gives you the sigma, the standard deviation of two independent random variables. If you add them together, again, you just add them like this. You flip the page and go to page 392. Standard deviation of the difference is exactly the same, okay? There's no subtraction here. So let's flip the page and go to page 394 and look at let's look at the particular combining normal random variables here. Okay, let's look and see if we can combine or add or do whatever with the normal random variables. In other words, both of the variables follow a normal distribution. Okay, so let's go to the example on page 395. On page 395, says the diameter C of the top of a randomly selected large cup drink in a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01. So you have the lids. So this is an example. You have the lids, okay, which is a mu, and you have a standard deviation of 0.01, 3.96. 3.96 is it? 3.96, okay? The diameter of, the diameter L of this large lid, okay, if the rest follows a normal distribution of 3.98. So wait a minute, so this is not the lids, this is the cups. Okay, so this is the cups. So the first one we talked about were the cups. Now we're going to talk about the lids. The lids, we'll call it Y. The standard deviation, the mu is 3.98. And then the standard deviation of Y is equal to 0.02. Okay. Assume that L and C are independent random variables. Let the random variable D equals L minus C. So we're going to say D is lid minus cup. Okay? Why are we worried about that? What happens if the lid minus cup is negative? What does that mean? Will the lid fit the cup? What will happen to the lid? If the lid,
it'll fall into the cup.
It'll fall into the cup, right? Disaster, right? Okay, so you want this to be greater than 0, obviously, right? Okay, this is what we're looking at. Okay, A, describe the distribution of D. The distribution of D is what? So the distribution of D, so mu D is the same as the lid. We call the lid Y here, right? So Y minus X. So it'd be mu Y minus mu X. So it's going to be 3.98 minus 3.96, 0.02, right? What is a sigma D? The sigma D is equal to the square root of this guy 0.01 squared plus 0.02 squared, right? And if you do that, what do you get? 0.02224. Okay? So that's that. B, for a lid to fit on the cup, the value of L has to be bigger than C, but not more than 0.06 inches. Okay, find the probability that a random selected lid will fit the random selected cup. Interpret this value. So what they're saying is that the difference, the mu D, the difference, okay, we already know that the difference is going to go what? It's a normal distribution with a center of 0.02 and a sigma of 0.0224, right? And we want this to be between 0 and 0.06, is it? So 0.06? Yeah, 0.06 inches, right? So how am I going to find this? What do I want to use here? I want this guy here, right? Anybody tell me how to do this? Isn't this just norm CDF? Right? Norm CDF from 0 to 0.06, 0 to 0.06. This is the mu, this is the standard deviation, right? And if you flip the page and you do that, you get 0.777. I think so, that's what it's saying, right? 770, right? Yeah. So there is a 77.7% chance that a randomly selected lid would fit. In other words, 78% of the time, you're going to be okay. Okay. So if you're on this side, your lid is going to fall into the cup. If you're on this side, your lid's going to be too big for the cup and it won't clip on, is I guess what I'm assuming here, right? Okay. Everybody understand that? Everybody see that? Okay, so with that, we are done with 6.2. So we'll stop right here. Okay, so again, in review, right? We know what happens, how to calculate the mu. We're doing x plus y and x minus y, right? Because it's mu sub x minus mu sub y, or mu sub x plus mu sub y, right? And the sigmas, you square them and add them together and take the square root, okay?